Alright, today's video is all about general rules for carboxylic acids. So, for rule number 1, we're going to say that it is after attacking a carbonyl, always reform the carbonyl. Unless it's a R group or H group. Never kick these out. Okay, so let's go over an example where we can reform the carbonyl by kicking out a leaving group, and let's also go over an example of one where we cannot kick out the leaving group. So example 1. Let's say we have carbonyl with a chlorine, so an acid chlorine, and we have, let's say NaONe over here. And if we're going to draw on our partial charges, we know that this is a partial positive, this is a partial negative. We'll have our nucleophile come and attack our electrophile. That's going to kick out that pi bond up. So we'll have this. So now what we want to do is we know that our carbonyl is a lot more stable when we have our pi bond. So we're going to reform our pi bond. And the way that we do this is we're going to have to kick something out so that we don't exceed 4 bonds on our carbon, right? We don't want to break our octet rule. So now we have this. And that is our final product. Now let's go over another example where we have something that can't be kicked out. So an R group or an H group. Okay, so let's do this with MgBr. So we have a Grignard reaction, and we know that this here is our electrophile. It's going to come attack, kick that off. So we have an ethyl group here. Okay, and now we can see that we only have 3 R groups, which we know cannot be attacked. So what we're going to do is we're just going to add on an H3O+. So this O is going to come grab a hydrogen, and our final end result is that. Okay. Cool. So that is rule number 1. Gonna erase this really quickly. And now we'll start on rule number 2. This is going to be expanding off rule number 1. So, if a leaving group is present, H and R groups attack twice. Okay, so this is really important. So let's look at some examples where we have this. So an acid chloride again, and we'll add LiAlH4, and then our second step is H3O+. So the end product of this is going to be, so you can see that we added on 2 H's. So the first time we're going ahead and kick that out. And then we're going to do it one more time. So, additionally, you'll see if we want to do this with a Grignard. And then adding on H3O plus, that we'd get an OH with 2 methyl groups. And that reaction looks something like that. Comes in, attacks. That comes down, that kicks off. Now we have double O ME. Well, our Grignard can come, attack again, kick that off. And now you'll see it'll come attach. And that's how we get our final end result. Okay, so those are our 2 big rules that will be applied with all acid chlorides and just understanding how you're going to predict the product for them. The last thing I want to do in this video is quickly go over a general outline of the reaction. Okay. So, let's say we're looking at a simple and common reaction like this one. Okay, so we know that this OET is going to come, attack here, kick that up here. Then that is going to be O neg, chlorine, OET. So the first thing, we're attack the carbonyl. Then we're going to reform our carbonyl. Right, so this is our beginning. Intermediate. And our end. And these arrows, this is going to be where we attack the carbonyl and reform the carbonyl. So looking at these reactions, these carboxylic acid derivative reactions, you can pretty much always see that the 2 main steps are attack the carbonyl, reform the carbonyl. And I definitely encourage you to go through a lot of the mechanisms and try to see this same pattern occurring over and over again. All this information that I'm sharing with you today is from Mastering Organic Chemistry as a Second Language, or Organic Chemistry as a Second Language is what I meant to say. And I would definitely recommend going to them and reading the section. It's really useful. They provide a lot of extra practice problems if you're struggling with it at all. Thank you.